questions we want to see do go over on the chart, right? So I'm thinking the most are 3, 4, and 5, so we'll do those 3. All of these can be done in Desmos, and then we'll just graph the last one. So for number 3, if you type in this whole thing, we would see that this is a line at x equals 1. So that is one solution. You don't need to write the x equals 1 part, but you do need to say that it's one solution. If you are not using Desmos to figure these out, you should be trying everything in Desmos as much as possible as your SLO is fast approaching. Make sure that if you didn't show work that you said use Desmos. Questions on that one? And number 4. If I type in this order here, I just do that. And I type in the equation given. I need an equation that's perpendicular, so the slope has to be the negative reciprocal of this, so you could either look at the graph and flip it, or look at the equation and flip it. So our new slope is going to be negative 4 over 3. But I need my y equals mx plus b. Add in my sliders, change my m to that perpendicular slope, negative 4 over 3. And then I was going to say move the b until it goes through there, but it happens to be there at 1. So then your equation would be y equals negative 4/3 x plus 1. So again, if you did that by Desmos, say that you use Desmos. I'm going to type in number 5. I'll write that down also. Negative 4/3. And then after we type it, we'll see what it looks like, see what the slope is, a y-intercept, and then graph it like that. So I see that this is a dashed line shaded below. Y-intercept is at negative 3. The slope looks like it's 1. So then when we graph that on the graph, it would look something like start at negative 3, go up 1, the right 1. You just leave it as dotted instead of dashed. Down 1, left 1. Draw arrows at the end, and shade underneath. Questions on any of those? Alright, today we're starting Unit 10, which is a lot of quadratics. I may have said that word before. We dealt with quadratics, but never actually used that word. Today we're going to start learning about what is a quadratic, what it looks like, how to graph it, things like that. So look at these notes. I'm going to pull up what you need to write down, and you guys can just start writing things down as I'm talking. So quadratic equations are written in standard form. We talked about that in ABC order, highest exponent to lowest exponent. Y equals ax squared plus bx plus c. We just talked about that with factoring, the trinomials. So usually our trinomials are quadratics. When we graph it, it creates a U-shaped curve called a parabola. So we've seen this U-shaped curve, but we didn't know what it was called, but now we have a name for it. To the best of your ability, I want you to draw these two rough sketches. Draw in the axes, draw the U-shape, make sure there's a point on there that says vertex, and draw this dashed line through it. To the best of your ability, it doesn't have to be perfect. And a couple things we'll need to be able to recognize and know is that when this U-shaped parabola faces up, if it's positive, if the A value is positive, it will face up. If the A value is negative, it will face down. So we've learned what it's called, what the shape looks like. Then there are other characteristics that we're going to be learning about. One is called the axis of symmetry. That's that dashed line that you drew. You won't actually see that, but it basically splits the parabola in half. The actual definition, the vertical line that divides the parabola into two equal parts. There is a formula to find the axis of symmetry. Does anyone still need these two graphs? That formula is this, so make sure you have this. X equals negative b over 2a. Do we have numbers? Yes. And after you do that formula, you get some x equals some number, and that tells you it's a vertical line. And it would be some dashed line that's not actually there, but we could split the parabola in half from there. Some other new vocab, the vertex. This is usually sitting at the top or bottom of the parabola, depending on which way it's facing. This is the turning point of the parabola. Usually it goes up and then comes down, or it goes down and then comes up. And at the vertex is where it changes direction. We're going to find that vertex by looking at either the lowest point or the highest point. The lowest point is called the minimum, highest is the maximum. So we'll be doing a bunch of new things with quadratics. Once everyone has these, we're going to start just doing the basics. Finding the axis of symmetry, finding the vertex, I think that's what it is, and drawing a rough sketch of what it would look like. That way, this will give us practice for when we actually graph it. Make sure you have these two on the side, the x equals the axis of symmetry and the vertex x comma y in parentheses. Alright, so we're going to start at number 1. At the bottom. So we're going to find the axis of symmetry and the vertex. I'm going to show you how to do this algebraically. I'm also going to show you how to do it in a calculator. You need to be able to do it algebraically. You could double check yourself in your calculator. Alright, so I'm going to rewrite that formula x equals negative b over 2a. Remember that this is our trinomial that we were just factoring a couple days ago. So in front of x squared is a, the middle coefficient is b, the last constant is c. So if you want to label those so you know which one is which, do that. And then to find our axis of symmetry, we're going to take whatever the numbers are and put them into this. So x equals negative 8 over 2 times, what's our a value?
X squared.
1. Just the number. And then simplify that. You can do that all at once. Negative 4. So our axis of symmetry is x equals negative 4. You have to have the x equals, otherwise it's not your axis of symmetry. It has to be an equation. Question so far? Then we're going to use that to help us find our vertex. We're going to take that number and we're going to put it in for all the x's we see. Make sure you're using parentheses for your negative numbers. Now, as you're doing this by hand, algebraically, I need to see this part, whether you do that all in the calculator or do it each by hand, each piece by hand, and then simplify it. That part's up to you. But I need to see that you put this in here. So you guys can either put it in the calculator or start to simplify it. I'll do that up here. What would y equal?
Oh, wait.
Should be negative 1. So when you put that into your calculator, make sure you're using parentheses. Make sure you're squaring. Figure out what the reciprocal was. Plus 8 times negative 4 plus 50. Should give you negative 1. Be careful with your math as you're simplifying if you're doing it by hand. So then your vertex is going to be negative 4, negative 1 in parentheses.
Is it the small vertex, right?
It's xy. Right, then we're going to draw a rough sketch. So draw in axes, x and y axes. Draw a rough sketch of where the vertex would be. And draw your axis of symmetry, that dashed line through it. Looking at our a value, it's positive. Would this face up or down?
Up.
Up. So then from here, you're just going to draw a U shape, up, facing up. It doesn't have to be perfect, just try to make it symmetrical. So that is a positive graph, yep. Positive parabola or positive quadratic, yes. Questions on anything we just did? Should we look at this a value? It's positive. Alright, go on to the next page. We're going to do number 2. Same process. If you need to rewrite that formula, x equals negative b over 2a. And let's do that for our axis of symmetry. Go ahead and put in, if you want to label all your coefficients and constants, you can do that. And x equals negative 10 over 2 times, what's our a value? Negative 1. What would our axis of symmetry be? X equals 5. From there, put 5 into all of your x values. And either put that into the calculator or simplify each piece. What is y?
2.
2.
What did you I thought 25 was negative.
So our vertex would be 5, 2. Draw in your axes. Do a rough sketch of where your vertex would be. Draw in your axis of symmetry as a dashed line. And then looking at your a value, would this face up or down? Down, because it's negative. So we're going to draw a parabola that's facing down. Do you have any questions so far? Sam, you look like you have a question.
Sorry, but what did you say? Negative. All of them are progress x equals.
Alright, we're going to skip down to actually. Let's do one of these. I'll let you guys choose 3 or 4. 4, okay. And then you might have time to do 1 or 2 more, and we'll do 8 and 9. So for number 4, again, find your axis of symmetry. How would we set that up?
Negative 4. 2 times 4.
2 times 4. So what would that axis of symmetry be?
Negative 1.
X equals negative 1. And then go ahead and start finding your y value for your vertex. What is your y value? Negative 5. So your vertex would be what? -1, -5. Go ahead and draw that row sketch. With this face up or down? Up. Once you get the hang of how to find the axis of symmetry, how to find the vertex, it's not so bad. I said I was going to show you how to do this in the calculator. So we'll do this for the next one. We'll do it algebraically and then do it in the calculator afterwards. Questions so far on any of this? Alright, let's jump down to number 8. First off, what are we missing in this? So it's not going to affect anything here, but the next one will. How would we set up our axis of symmetry here?
-1.
So what would that axis of symmetry be?
X
Equals what?
2.
X equals 2.
You guys see the
Alright, and then put that in. And figure out what y is. It is 4. So vertex 2, 4. And then draw that row sketch. With this face up or down? Down. Great. In your calculator, go ahead and type in y equals -x squared plus 4x. I'm just trying to reset my whole calculator. Okay. In y equals, type in -x squared plus 4x. And then go into the table, second graph. And when you go into the table, as you're looking at your y values, they're going to start repeating. And as they start repeating, you're going to find the point in the middle. What would that point be? 2, 4. That's your vertex. So that's how you could check yourself in the calculator. And then find your axis of symmetry by just looking at the x value. To see if your sketch, or later when we graph, if your graph is right, you could plot these points, double check these points. You could also look at the graph itself. Kind of similar on Desmos, if you typed it into Desmos, just so we are all on the same page with was it plus 4x? Yes, okay. So if you graph that, if you put that into Desmos, you could easily see what the graph looks like, that it faces down. It's going to show you your vertex point, so you can see what that is. Again, you see your axis of symmetry is not actually drawn, but it does split it in half. If you actually wanted to see the points, you could change it to a table. Go into the gear wheel, make the table, and then it shows you the points. And you could add in more. So use Desmos while you're practicing and the calculator to double check yourself, but make sure you show the work. And then number 9, what's missing there? the b. The b is missing because the x by itself, or the constant, the coefficient with x is missing. So we have a, we have c, we don't have b. So when we put b in, we're going to put 0. So that would be x equals -0 if we're keeping with the formula over 2 times 1. Which means the axis of symmetry would just be 0, x equals 0. So anytime you don't have a b value, your axis of symmetry is automatically x equals 0.
Do we have to do all of that?
Still, yes. I have to show vertex. And then if I put 0 in, what's your y value?
0.
-3. -3. So then our order, our vertex would be 0, -3. And then go ahead and graph that vertex. So since this, the axis of symmetry kind of falls on, it doesn't kind of fall on the y-axis, I'm just going to highlight it. You may want to do that, or just draw dashed lines extending the y-axis. And then with its face up or down? Any questions on this? So on Monday, we're going to get into the actual graphing piece using what we just learned, adding a little bit more characteristics, and then we'll talk more about that. For like 5 minutes, practice either this, Delta Math, SOL practice, JLab, and then I'll have you guys get yourself up.